Alright guys, today we're going to be doing segments instead of angles. So we're actually finding lengths of segments created inside and outside circles. So the first one is if you have two chords that cross inside of a circle, then the product of those lengths, right, multiply those lengths, should be equal. So A times B should be equal to C times D. I call this chunk times chunk. Chunk times chunk. So A times B should equal C times D. Chunk times chunk. So they give you a little example here. We'll talk about it. So 6 times X should equal 8 times 3. Or 3 times, it doesn't matter which way you say it. 6 times X, 6X, should equal 3 times 8, 24. All right, and that's where this comes from over here. We have 6x equals 24, divide both sides by 6, and you get x equals 4. So that's one example. Let's try a couple more. Here, 2. So again, we see they're crossing inside the circle. 2 times x should equal 3 times 6. So we got 2x, 3 times 6 is 18, x equals 9. All right, and again, look back to your problem. 2 times 9 is 18. 3 times 6 is 18. Next one. Chunk times chunk should equal chunk times chunk. So we've got 6x equals 64, and we're going to divide both sides by 6. Now the directions here do say round to the nearest tenth if necessary, because I know 64 divided by 6 is not pretty. So you get 10.6666, which we're going to round to nearest tenth, 10.7. 10.7. We're going to skip number 3. If you're interested in it, it really doesn't use the theorem that much. Notice this is a radius, this is a radius, this is a radius, this is a radius. A radius should always be the same length in a circle. So if they're telling you it's 5, then x plus 2 has to equal 5. So it didn't really use this theorem, but it just had a bunch of radii. This one does, though. Chunk times chunk, so we have 2x times 3x has to equal chunk times chunk, 6 times 5. So we've got 2x times 3x, which makes 6x squared, right? X times x is x squared. 6 times 5 is 30. We're going to divide both sides by 6. We've got x squared equals 5. And the opposite of squaring is square rooting, so we're going to take the square root of both sides. So we've got x equals the square root of 5. And again, it did tell me to round to the nearest tenth. So when I type this in my calculator, I get x equals 2.23, which we would round to 2.2, nearest tenth. All right, so that's when they cross inside of a circle, talking about segments now, not angles. They could also intersect outside of the circle. They could intersect outside the circle. And these are usually tangent and secants. Where over here we were talking about chords. Right, this is a chord, they're crossing inside the circle. Here, this is a secant. Right, a secant crosses a circle twice, once, twice. And another secant, again, intersecting outside the circle. Or you could have a tangent, right? This is a tangent AB because it hits the circle once. So secant hits the circle twice, tangent hits the circle once. It really doesn't matter which one you're working with. If they cross outside of the circle, that's when you use this stuff. So what I have to remember this one with is chunk times whole. So what do I mean by chunk times whole? So if you're looking in this example over here, AB is your chunk, right? AC is the whole thing. So AB chunk times whole AC. AD is your chunk, right, outside. And AE is the whole thing. So AD times AE, chunk times whole. Over here, they make it look like it's something different and a whole new formula. It's still the same thing, except for here, AB is your chunk and AB is your whole. So it would be the AB times AB, and that's where they get the AB squared. It's still the same concept, okay? Chunk times whole, they just happen to be the same. They did an example for us over here. So chunk times whole, so that'd be 18 times 18. Chunk is 18, the whole is 18, equals chunk 15. Right, 15 is my chunk. And then the whole thing is 15 plus x. 15 plus x. All right, because if I told you x is 1, you would tell me this whole thing was 16. You would add them. So if it's x, you do the same thing, 15 plus x. And then you distribute that 15, do your multiplication, so you get 324. 15 times 15 is 225. 15 times x is 15x. All right, and that's where this came from right here. We subtract 225 from both sides. We get here, and we divide both sides by 15. All right, let's try a couple of examples on our own here. So here, chunks, we see they're crossing outside. Chunk times whole, all right, which just happens to be the same here. Here, chunk is 2.2, right, little chunk right here, and then the whole thing is 2.2 plus x. We're going to do a little multiplying here. So we've got 3.3 times 3.3. We got 10.89. We are not rounding yet, so don't round. We're going to distribute that 2.2, so we're going to multiply 2.2 times 2.2, 4.84. And 2.2 times x is 2.2x. We're going to subtract 4.84 from both sides. So we've got 10.89 minus 4.84, which gives us 6.05 equals 2.2x. And we're going to divide both sides by 2.2. And it does say round to the nearest tenth, so we got x is about 2.8. There's 2.75 to the nearest tenth is 2.8. All right, next one, chunk times whole, so 6 times 6 plus 4x. All right, the whole thing is 6 plus 4x. Should equal chunk 6 times whole 6 plus x plus 3. 6 plus x plus 3. Add them up. So here 36, we're going to distribute 24x. Here we're going to combine our like terms in here, 9 plus x. Now we can distribute. So 6 times 9 is 54. 6 times x is 6x. We're going to subtract 6x from both sides. We're going to subtract 36 from both sides. And x equals 1. So that one we didn't have to round. Now, I do want to show you with an easier one too. You can always plug this in and test it out. 4 times 1 is 4. 1 plus 3 is 4. So you're telling me 6 times 10, right? The whole thing is 10, should equal 6 times 10. Which it does. 60 does equal 60. So you can always plug it back in and check. Alright, last but not least. Chunk times whole, so 8 times 8 plus 2 gets me 10. But I'm going to write 8 plus 2 just so you know where it came from. Chunk times whole, x plus 11, the whole thing, add them up. So we have 8 times 10 is 80, x times x is x squared, x times 11 is 11x, and this is a quadratic. This is a quadratic. When you see an x squared, you know you're dealing with a quadratic. So we want it to equal 0. We're going to subtract 80 from both sides. So we have 0 equals x squared plus 11x minus 80. All right, and we want numbers that multiply to negative 80. So multiply to negative 80 and add to 11. Multiply to negative 80 and add to 11. So I've got negative 16 and positive 5. So if you multiply these, negative 16 times positive 5, you're going to get negative 80. And if you add these, negative 16 plus 5, you're going to get positive 11. So we're going to go ahead and factor this. So we have x minus 16 and x plus 5. The reason you do this is because now if this is 0, it works. If this is 0, it works. So x minus 16 can equal 0, or x plus 5 can equal 0. And we're going to get two answers. We're going to add 16, x equals 16. And we're going to subtract 5, x equals negative 5. Now, in geometry, in Algebra 1, both answers work. In geometry, only one answer makes sense. We're talking about a length here. We want to know the length of TQ. So when you're talking about the length of TQ, we definitely don't want negative 5. So our answer is going to be 16. So yes, sometimes you get two answers, but you want the one that makes sense geometrically. All right, so your homework. The first page is very straightforward, the chunk times chunk or whatever it is. And then they do get a little bit harder on the second page. But just tell me if you need help going through them. Again, remember the difference between chunk times chunk or chunk times whole, right? Tell me if you have any issues. Get it done. Make sure all your work is shown. Bye, guys.